Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the second unit of Basic Electronics, that is application of diodes. So here we will see about LC filter, that is inductor capacitor filter. The circuit diagram for an LC filter is used with a full wave rectifier as shown in figure. Here you can see this is a full wave rectifier circuit and along with the L, that is inductor and capacitor filter. This combination of inductor filter and capacitor, this is a combination of inductor filter and capacitor input filter. Inductor filter is preferred for low values of R and the capacitor input filter is preferred for high values of load resistance. The LC filter can give low ripple factor irrespective of the load as it is a combination of the two filters. The series connected inductor offers a high reactance to the harmonic components, that is in the output, and attenuates them, and the parallel capacitor provides the low reactance bypass path for them. This will reduce the ripple further. Now here it is the circuit diagram of full wave rectifier with LC filter. You can see this is the circuitry of full wave rectifier. This is the inductor, capacitor. This is the RB. RB is the bleeder resistor which is additionally connected in this LC filter circuitry. And this is the load. Across the load we get the output of the filter. Now role of the bleeder resistance, that is RB. The resistance RB connected across the capacitor is called as a bleeder resistance. It is used to maintain a continuous current through the filter inductance L. If the current through L is not continuous, that is if it is interrupt, then the large back EMF, that is L into di by dt, will be developed across the inductor. This voltage may exceed a PIV, that is peak inverse voltage rating, of the rectifier diode and damage them. This voltage may exceed the maximum rated voltage of the capacitor as well. Hence, the induced back EMF is dangerous for diodes as well as capacitor. The back EMF will not appear if the current through L is continuous. RB will maintain a continuous current through L. Expression for the ripple factor is R is equal to 1 divided by C square root of 2 omega square L into C. The load resistance R is not present in the expression of ripple factor. This indicates that the ripple factor of LC filter does not depend on the load resistance at all. It remains constant for all the values of load. This is the biggest advantage of LC filter, so we can use it for the heavy as well as light loads. Now next type of filter is pi filter or CLC filter. So here the diagram for pi filter or CLC filter, combination of capacitor, inductor and capacitor, followed by the full wave rectifier circuitry. The pi filter, which is a combination of capacitor input filter and LC filter, is shown in figure. It consists of two capacitors C1 and C2 along with the inductance L. Generally both the capacitors are of same value. A full wave rectifier drives the pi type filter as shown in figure. As C1 comes first, looking from the rectifier side, the pi filter behaves in a very similar way as the capacitor input filter. All the advantages and disadvantages of capacitor input filter are all applicable to the pi filter as well. A pi type filter can be considered as a combination of shunt capacitor filter and LC filter. This improves the effectiveness of the pi filter as far as filtering of ripple is connected. Due to the use of three filtering elements, that is C1, L and C2, the ripple factor of the pi type filter is very low as compared to the other filter. The capacitor C1 and C2 provides a low reactance path for the ripple, whereas the series inductor L provides a high reactance to the AC ripple. The combined effect of this is the reduction in the ripple and improvement in the output waveform. Now this is the waveform of pi filter or CLC filter. Now comparison of C, L, LC and pi filter. So on the basis of this parameter, we'll compare shunt capacitor filter, series inductor filter, LC filter and pi type filter. First parameter is component used. In C filter only capacitor is used, L filter only inductor is used, LC filter one inductor and one capacitor is used, and in pi filter two inductors and two capacitors are used. Second point of comparison is place of filter. In C filter across the load, in L filter in series with the load, in LC filter again across the load, and in pi filter again across the load. Next parameter is load regulation, is poor for C filter, is moderate for L filter, is good for LC filter and it is very good for pi filter. Next parameter is ripple factor. It will be low for C filter, it will be high for L filter, it will lower for LC filter and lowest for pi type filter. Size of filter is small and compact for C type filter, is bulky for L, LC and pi filter. Cost wise, C type filter having the lowest cost, L type filter having moderate cost, whereas LC and pi type filter having higher cost. Next parameter is used in C type filter are used for reducing the ripple in the load voltage. L type filter used reducing the ripple in the load current. LC filter are used for reducing the ripple in the load current, and pi filter are used to reducing the ripple in load voltage. Next parameter is suitable for. It is suitable for light loads. C type filter are suitable for light load. L filter suitable for heavy loads. LC filter suitable for light as well as heavy loads, and pi type filter suitable for light loads. Next parameter is application. C type filter, it is used in cell charger, small eliminators, etc. L type filter is used in high current DC supply. LC filter are used in DC power supplies, and pi filter are used in DC power supplies. So these are the comparison between the filters. Thank you.